I'll back up. I think we got to at least write the equation for the first example in our notes on Friday. Okay. Just in case you don't have it in front of you, this is the equation I'm working off of. H equals negative 16t squared plus 60t plus 4. This is from that first example in your notes. I'm going to go ahead and type that into my calculator, and you can go ahead and do this with me. Oh, I need a calculator that works. That's what I used to teach my first hour class. I loved it. Okay. Okay. Mine's actually already got that typed in. Where's my light? Okay. I used an x instead of t, but this is under y equals, and then I typed in this equation, negative 16x squared plus 60x plus 4. Okay. Now, if you hit graph, your calculator may already be set to give you a nice, pretty picture. It might not. In fact, let's make it so that it doesn't show us a pretty picture so I can teach you how to handle it if it's not. So hit zoom and number 6. And that's going to take you back to a regular screen. And it's going to give you this. Okay. Check your equation again under y equals. Make sure you have the same thing I have. Okay. Under y equals, check to make sure you have the same thing I have. And then hit zoom and number 6. Plus 4. Okay. You might have already had it because probably people did the same problem first hour. Okay. So, okay, the problem with this picture is you can't really see the top of the parabola. But I don't need to look at all this other space. So we're going to talk about how to set your window. And down at the bottom of your page, I'm going to give you some hints for setting your window. Hit graph. Oh, hit zoom number 6. The equation is in your notes, but it's this right here. Negative 16x squared plus 60x plus 4. Okay. In your calculator, there's a button that says window. And what that controls is that lets you say how much of the graph you want to look at. Okay? So if you hit window, if you're in standard mode, which is what you did when you hit zoom and number 6, you changed it back to standard. Devin, what's wrong? You forgot the negative. There you go. Okay. When you're in standard mode, this is what this should look like. What does x represent in this problem? Remember, we put x in place of t.
Time.
So time. Okay, so do we need to go back in time?
Yes.
So what's the smallest times that we need?
We need a time.
0. Yeah, the smallest time we need is 0. So where it says x min, we're going to make that 0. Okay. Now for your x max, that wants to know, well, how much time do you need to see on this graph? Well, I want you to think about this. If you're throwing a ball up in the air and waiting for it to come back down, okay, you are not Superman. So it's not going to take a super long time. How long do you think it might take?
3 seconds.
Okay,
4,
3
7.
seconds, 4 seconds. Maybe let's go to 5.
7.
Because, well, I want you to be realistic. You're better off guessing too big than too small. So I'm going to go to 5 seconds. Now, what does y represent in this problem? We used y instead of h.
Height.
Height. Okay, so what's the smallest height that we need? 0, because we're not going underground. So your y min, I skipped x scale, leave that alone. Okay, y min I made 0. Now y max is a little bit trickier to kind of pick, because you kind of have to say, how high do I need to see my graph? Okay, how high do you think this might go? Take a guess.
60.
60? Okay, this is probably the hardest part for people, is figuring out what to set your window at, because there's no set rule. Okay, so I'm going to make my y max 60 and we'll see what happens. Okay, so as a rule, I would always make your minimum 0. Your x min and your y min 0.
What's triangle x?
Okay, that is asking you, what do you want x to count by? Like, how much do you want it to change by?
Now.
Let's hit a graph. Oh, we are very close, but it looks like we're missing just a tiny point up at the top.
The scale.
So nope, we're not going to change the scale. We just want our y values to go a little bit higher. Okay? So I'm going to go back to window, and instead of 60,
65.
I'm going to go 65, just to give myself a little space. Here's what happens with these.
Nope, doesn't work.
Still doesn't work?
Nope.
Okay, so let's go maybe 70.
How does it work? I don't even know what we're trying to do. What?
Okay, okay. Here's what happens with these. When I tell people to guess a number, we'll do something like this, and I'll say, okay, 60, and we'll graph it, and it won't be high enough. And I'll say, okay, guess something bigger. And they'll say 61. And then I'll say, no, guess something like a lot bigger. And they'll go, okay, 65. Okay? When I say guess bigger, okay? It is okay for you to guess too big. I would rather you guess too big than too small. If you guess too big, you're going to have blank space at the top of your graph, but that's fine. If you guess too small, you're not going to see your entire graph. Okay? So if we go 65, can we see the top of the parabola? We sure can. Okay, so we're good. As soon as you can see the top, you're fine. Okay? So as a hint for you, for setting the window, and I would jot this down just at the bottom of your page, to set your window, I would always make your x min and your y min equal to 0. And then I want you to remember that x represents time and y represents height. Okay? Yes. Well, here, just take this one. Okay, I've got my one from first hour you can take. Okay. We haven't filled in all the other boxes yet, but we just set up the outside of it so far. Okay. And then set your maxes accordingly. But guess big. Again, guess bigger than, I'd rather you guess bigger than too small. Okay. And then just so you know, if you want to reset your window to go back to like a normal graph screen, you would hit zoom in number 6. Okay? So x min and y min are going to be 0. X is your time, y is your height. Set your maximums to where you think they should be. And sometimes you're going to have to guess and look and then go back and guess again. Okay? And then if you want to get back to a normal screen, hit zoom in number 6. Okay, so now that you have it on your graph, let's talk about how to do these things with it. Okay? And what I'm really going to show you is how to find the vertex, but that would be if the question asked you to find the maximum height.
The knife is cutting out.
Okay.
You only did it once.
Okay. Okay, well, it's probably just buried. It's fine. So if the question asks you something about finding the maximum height, let me see if I can fix the brightness here a little bit. That's pretty bright. Here's what you're going to do. Write this down first, and then I'll demo it, and then you'll try it. You're going to go to the Calc menu and choose Maximum. It's going to ask you to set your left bound, and I know this doesn't make sense yet, but set your left bound and your right bound. Hit enter, and it's going to give you a coordinate. Remember, x is time, y is height. Okay. So write that down, then we'll talk through those steps. And as we're talking through the steps, if there's anything you want to add to your notes, you can. Okay. Oh, Jotea, first hour we switched these two columns. We did them in the opposite order. It doesn't really matter. Just make sure that you're writing stuff down in the right place as we're going through it up here. Okay. Just remember that. Okay. So, again, I would recommend that you watch this first. the calc menu is up above the trace key. So I'm going to hit second and calc. And then you should see an option that says maximum. It's number 4. Now when I choose that, it's going to say left bound. Okay? Which means it's asking you how far left do you want it to look. You're trying to focus it in on the vertex itself. You're trying to say, here, look for the top value. So when it says left bound, I'm going to move my cursor over to the left. I just want it somewhere to the left of the bump. It doesn't matter where. And then I hit enter. Then it's asking me for right bound. So now I'm going to move my cursor back over to the right. Somewhere to the right of the bump. Again, it doesn't matter where. You're just telling your calculator, find me the maximum between here and here. And then when it says guess, you hit enter one more time. And it gives you 2 values down here. X is your time, Y is your height. So this means at 1.875 seconds, the ball is 60.25 feet in the air. Okay? And that's your maximum height. Now you try it. Calc menu. So hit second and the trace button for the calc menu.
Yeah, 4.
Where do I go from here?
Maximum.
Maximum, number 4. It's going to say left bound. So move your cursor to the left of the bump. Hit enter. The top. You want the top, like where the top of the parabola is. Go to the left, the right. Then I'm going to go to the right of the bump somewhere and hit enter. And then when it says guess, hit enter one more time. Now see, this one came out just a little bit off. Sometimes it does that just because of the pixels on the screen. It was really 1.875, and this time it came out to 1.87499. That's okay, it's the same value. We round anyway, so. Did you get those numbers?
Number 4?
Well, did you get those answers down at the bottom? And you did the whole process. Okay, bring it on up. Anybody else having trouble following those steps? Evan, bring it on up.
So regardless, we should have what's on the bottom.
Yes.
Similar.
Yeah, similar. It might round a little differently, but it should be those same numbers-ish. Okay, I'm going to hit calc, maximum. And when it says left bound, move to the left of the bump and hit enter. Right bound, now I'm going to move to the right and hit enter. See those arrows? That's saying you want to look between there, and then you hit enter one more time. And there are your numbers.
Oh.
Okay. Okay, you didn't enter that last time? Okay, you didn't set your window with us. Okay, we talked about how to set this window. You want it to look just like mine. So 0 to 5 and 0 to 65. Okay, then you're going to do calc, which is up above trace. Maximum. Left bound, you want to move somewhere to the left of the bump and hit enter. Gentlemen, can you stop that? Right bound, move somewhere to the right of the bump and hit enter. And then when it says guess, hit enter one more time. And there are your numbers. Okay? All right. Now, here's the thing. What we just did really was we found the vertex. But you already knew how to find the vertex. How do you find the vertex of any quadratic equation? H and K, right? How do you find H?
Negative b over 2a.
Yeah. Yep. I do have those graded, by the way. I'm hoping to get them back to you today, but I want to make sure we get through this stuff first. Okay, so if you didn't want to do all of that on the calculator, you could take that original equation, you could take this right here, and do the negative b over 2a thing. Like for this, it would be negative 60. I'll show you. In a regular calculator screen, negative 60 divided by 2 times my a value, which is negative 16, and I forgot the parentheses. Yep. Not right now. Okay, don't want you to miss this stuff. And I get that 1.875 that we had just a second ago. And then we could take that 1.875 and plug it in for x, to find our K value, which should come out to that 60.25. So if you didn't want to use the calculator for that, you could do this same process that you already know how to do. How are you feeling on that? That's probably the most complicated one. Okay, let's talk about finding a Y value, which is what's going to happen if it asks you to find the height at a given time. Okay? So if I say, what is the height of the ball at 3 seconds? Okay, this is how you would do that. And again, I'm going to have you write down the steps. I'm going to show you the steps, and then you'll do it yourself. Okay? You're going to go to that calc menu again and choose value, which I believe is option number 1. Okay? Then you're going to enter whatever X value you're given. So if it wants 3 seconds, you would enter 3. If it wants 5 seconds, you would enter 5. Okay, so enter whatever value you want X to be and push enter. And the answer will be the Y value. Okay, so on your calculator, I've still got that same equation in my Y equals. And you'll notice from your notes that like this third question says, what is the height of the ball after 2 seconds? So I'm going to try to answer that. What is the height of the ball after 2 seconds? So I'm going to go to calc, which is above trace, second trace. Option number 1 is value. When I choose that, whoops, hit enter too many times. Calc value. See how it gives me X equals and then a little blinky box? That's where I'm going to type in what I want X to be. Well, if I'm trying to find 2 seconds, I'm going to put X equals 2 and push enter. And that Y value is your answer. So at 2 seconds, my ball is 60 feet in the air. Okay? So that's how you can do that from a calculator. What if you didn't have a calculator, or a graphing calculator at least? Or what if you didn't know how to get the graph up? Well, we did one of these at the end of that worksheet. That worksheet we just went over. The very last question was, how high is the object after 1 second? What did we do for that? Yeah, and we just plugged that number in, right? So, mathematically, you could just plug the value in for X or T, if you're in Newton's formula, and evaluate. If you're doing it that way, if you are plugging the number in yourself, you are doing this on a regular calculator screen, not the graphing. Okay, if you are plugging the number in yourself, you're not typing that into Y equals, you're just typing it into your regular calculator and evaluating. Just like we did right back here. When we did this, we put negative 4.9 times 1 squared plus 10 times 1 plus 1, and I just typed that into our calculator and solved. So you don't have to use the graph, you could just do it that way if you wanted to.
Why did you write something different down on this one?
What did I write different?
Plug time in 13 and then
Okay, well, by value I mean time.
okay.
In these problems, it's always time that you're plugging in. But what I want you to be able to do is take this sheet and see how you could use this for other problems that's not necessarily talking about time, so that's why it was a little more broad here. But that's what I meant was time. Okay? Does that make sense? Okay, the last question I could ask you, and this is finding a 0, is I could ask you to find how long until it hits the ground. And there's an easy way and a hard way to do this. Most of the time, the easy way is going to be enough. If the question asks you approximately, or about how long, you're going to be able to estimate just from looking at the graph. Okay, so if it wants an approximate answer, you can just look at the graph and count the seconds. On the x-axis. And I'll show you what I mean by that in just a minute. So if it asks you approximately, which I think most of them at this point in the game are just going to ask you approximately, in your graph, I'm going to click that. So I'm just looking at my graph. Your x-axis is your time, right? So these little dots are all seconds. How many seconds did it take for this to hit?
4.
Almost 4, yeah. So like if I was to answer that for this question, I would say about 4 seconds. Okay? If you wanted to find the value for real, if you wanted to know what the exact answer was, here's what you would do. You would go to Calc and choose 0. And then just like before, you're setting the left bound and right bound, but your left bound and right bound are different this time. I don't know why I'm writing press, but okay. If you did that here, the point you're looking for is this point right here. So when I say left bound and right bound, the left would be somewhere up here, and the right would be somewhere past the axis. Okay, so you're not doing the vertex this time, you're looking for this point. So left bound is going to be here, and right bound is going to be somewhere down here. So when I go to that calculate, I want 0, which is option number 2. Left bound, I'm going to move down a little closer to the 0, but I want to be somewhere up above the axis, so like here, and hit enter. When it asks for right bound, I want to make sure I move past the x-axis. When I go below the x-axis, what happens to my y values? When I go below the x-axis, what happens to y? What kind of y values are below the x-axis? Negatives. So I want to make sure when I'm moving, I'm watching these y values, and as soon as I drop negative, I know I've gone past the point that I want. So I hit enter, and enter one more time. And it gives me my x value of 3.81. Okay? Isn't that almost 4? Just what you shouldn't have to, no. Yeah. It's not going to, you're not going to be able to see your cursor. That's why I told you to watch the y values. Because it is going to go off the graph because we had ours stop at 0.
What?
Bring it up here. Okay. Relax. Okay. Oh, you did reset your window somehow. Yeah, you wanted to leave the window as it was. Oops. There you go. Oh, and I think you maybe erased your equation too. You want to put that back in. Okay. Does anyone remember another name for that point? What's another name for that point where it crosses the x-axis? We could call it a 0, or we could call it a, starts with an R. Oh, come on. Root. Remember the roots? How did we find roots before? Oh, come on.
Oh, that one thing we did in J2J.
Okay, that was vertex. Okay, what you're talking about is the discriminant.
Oh, quadratic formula.
There you go. The discriminant tells you how many roots you have, but then if you actually want to find the roots, you're going to use the quadratic formula. So if you wanted to do this mathematically, you could plug a 0 in for y, or for h in these problems. And you could solve with the quadratic formula, just like we did before. So I could take this equation, put a 0 right here, and then do my A, B, and C, use the quadratic formula, and solve and get that same answer. But I really encourage you to pay attention to how the question's worded, because again, anytime it's asking you for an approximate answer, it's much easier just to look at the graph and count the seconds. Okay? If you had to find an exact value, you could do one of those two things. Okay? The reason we spent all this time doing this today was not just to review how Newton's formula works, but it's also so that you can see all of the different things you could do on a graphing calculator. You've learned how to do all of these mathematical things already. But if I give you a quadratic equation and I say find the vertex, you could use those same steps we wrote down a second ago. Okay? I do have an assignment for you on Newton's tonight. We're probably pretty close on time. Okay. Here's what I'm going to do. I'm going to give you the assignment. I want you to do as much of it as you can. And there's a lot you can do without a calculator. You can write out the equations. The ones where you just have to plug the numbers in, you could do that piece of it. There's 2 problems on there where you're given a graph and you just have to read the graph. Okay? So do as much of it as you can tonight. Tomorrow when you come in, you'll have time to finish it up if you need the graphing calculator to finish it. But don't save the whole thing for tomorrow because you'll lose your whole test review day. Okay? And anything you need from me, if you have anything that you think would be helpful if I put it up online or something like that, email me, okay, and tell me, hey, it would really help if you put a review on how to do the quadratic formula online. I'll do it. Okay? So just let me know what you need. Okay? Give this assignment a shot. This will be due at the end of class tomorrow. So if you need time to finish it with a calculator tomorrow, you can use it. Okay? And I'm also going to put up the video of the worksheet we went over today and this organizer that we did together today. So if you need to review any of that, you can. Devin, did you get one of these? Yeah. Yes.
I need you to like walk me through.
Okay, sure. Yeah, let me pull out. And you have lunch right now, right?
Oh, look at that.
Can you believe that? I read this one place and I learned about that.
Okay. Take that and run back to your seat. I will be right over there. Oh, yeah. Oh! got the 120, you found the area of the rectangle. What I want to know is what length would I have to make the square in order to have it match the area of the rectangle?
Well, I got the area that's for 80 and then I divided that by 4.
Okay, I think you may have actually done, all right, when you're finding area, you just multiply the two sides. So this is 10 times 12, this is 120. But then this, remember in a square, this side length and this side length are exactly the same. So when you go to find area, you end up with x times x, which is x squared. Okay. X squared, then we have to equal. Okay. X squared would have to equal that 120. Okay. And then how would you solve that? Yeah. So that's what I'm doing. Okay.
The Tyler,
This one,
take experiment
except that right here, when you take that square root, you take a square root of 36 to get that alpha. You also get negative root. Every time you take a square root, you get 2.
Oh, yeah.
Okay, yeah, you got the second one. So then you would have g plus 2 equals negative 6, and then you have to solve that. Yeah, so you did this one, but we need another one that says g plus 2 equals negative 6. And then you would solve that and you would get negative 8. So you just missed that answer. This is right, but you missed it. Does that make sense? This one, don't take the square root until you get rid of the negative 2. Now it actually looks like, so you took the square root here and canceled out that square, but you still have these negative 2 sitting. Get rid of that negative 2 first, and what you would find is that you would end up with x squared equals negative 2.
If I, wait,
Okay, sure. Okay, we got rid of the 4, right? You subtracted the 4 from each side, and so you got 32. So then you have negative 2x squared equals 32. From here, before you take a square root, you can't take a square root until you have just x squared left.
so how do I get rid of the negative sign? Do I multiply?
Well, I would divide by negative 2.
Okay.
That's going to give you x squared equals negative 16. Then square root it, except that you can't take a square root of a negative number. This would be no solution. As soon as you get to this point where you're taking a square root of a negative, it would be no solution. Okay? Does that make sense? Okay. This one you sort of mixed up when you were adding and when you were multiplying. You had your picture set up totally fine. Okay? But if I want the length of this whole side, that's going to be 90 plus 2w. You made it 90w squared. Okay, so you want this to be 90 plus 2w. And then this side over here would be 60 plus 2w. Okay. Then if you want to find area, area is length times width. So you would want to multiply this times that. The FOIL. So you would do 60 plus 2w and 90 plus 2w. Okay. No? This one is the only thing you messed up, very tiny little thing here, is you knew to find the area of the big one and subtract the area of the small one, right? But when you're subtracting, you need to make sure you're subtracting this whole thing. So you're subtracting x squared and also subtracting 2x. So that 2x should be a negative, which would make that, so that's negative 5x, and that would be negative 2x, which would make that a negative 7x instead. Okay, everything else was good, you just forgot to subtract that second piece. Okay? This one was totally fine, except when you want the a value, you just want the number. No x squared there. Right, but that x is now in here. see I took that x and put it inside the parentheses. So now I don't need that x squared here because it's in here. Okay. Hey.
I didn't have
Oh,
to.
yeah.
So I am not gonna be here on Thursday,
Okay.
and that sort of messes up my construction plan because
Okay.
I wasn't thinking that. I wasn't thinking that first day of construction to leave it with a sub. I don't want to do that.
Right.
So I am toying with. I have review today and tomorrow because I know I was a day ahead of you guys, right? So I have review today and tomorrow, and the test is on Wednesday.
Oh, that's where I'm at too.
Oh, it is
Yeah.
where you are. Okay, perfect. But I guess what I might do is move my test to Thursday with
Okay.
the sub,
Yeah.
and then maybe do constructions on Wednesday.
And then
Would
finish
you?
Friday.
And then finish Friday. Would you even recommend?
I've done that.
Have you done that before?
Yeah.
Okay, I think that's how I'm gonna
Yeah.
do it, and then just sort of, in addition, maybe run like a study group after school on Wednesday or something
Yeah.
to just keep the momentum for chapter 8 going.
for sure. Yeah, that's what I've done that with my algebra classes before.
I would much rather be here.
Right.
Okay.
Yeah. We were all wrong. Very helpful. Okay, so then you've got that. Oh, and then you did also forget you're doing the square. Okay. To get to standard form from that, you just have to simplify. So you're going to take like this parentheses, x plus 5, and write it out twice. Are we doing this? Okay. This equation should say this. Y minus 5 equals negative 2 times x plus 5 squared. Okay? You're going to simplify this to get it to the standard form. You're going to have y minus 5 equals negative 2. This is going to get expanded. Then what? Yep, I would FOIL this, and then distribute the negative 2.
So you want me to have y equals something?
Right, that's what standard form is. Standard form is when it's just y equals and everything else is simplified.
Okay.
Does that make sense? So that's what you're looking for here. Okay. Okay, this one, it actually looks like you found the vertex. I see what happens here. This question A says give the vertex, which is this. You found it exactly right. But then the next question says I want the axis of symmetry, which is that.
Oh,
So
okay.
this should be your answer for that question. Okay?
Now, how did I get negative 2
Okay. You're looking at this. This said y minus 4 equals, oh, sorry, okay. And compared to vertex form, and the h and the k, they're your vertex. But remember this is sign is switch. So this is really a negative 3, and this is really a positive 4. The vertex is always h and then the k. Okay. So we looked at this compared to this formula, and then said, okay, this number must be my h value, except it should be negative. And this number is my k value.
Okay.
Does that make sense? Okay. And then, so then for your axis of symmetry, that's where you do the x equals the first number there. X equals negative 3. Does that make sense?
What's the vertex? Is this the vertex?
Yes. Yeah, this is the vertex. And then this is the axis of symmetry. Okay. You will write this down. If your a value is less than 1, like 1/2 is less than 1, then be y. Okay. And then your graph will be good. How do you feel? Okay, give it a shot? Yeah. Okay. I think actually, because I didn't print off any of the retakes yet, but I don't keep you there too long, so I'm just going to give you. You just write retake at the top of that, so I remember, okay?
Okay.